Hello friends, welcome in chemistry YouTube channel. In our GPAT examination, so there is one subject, that is physical chemistry. In physical chemistry, the one point or one concept is there, or one chapter is there, that is thermodynamics. In today's session, we learn about what is thermodynamics and how the questions asked on the basis of thermodynamics. One or two questions asked in the GPAT examination on the basis of thermodynamics. So first of all, what is meant by the thermodynamics? Let's learn about the thermodynamics. So thermodynamics is nothing but the science which deals with the study of different form of energy. Different form of energy and quantitative relation between them and energy changes during chemical and physical process. So this is definition of thermodynamics. It is branch of science which deals with the study of different form of energy and their quantity relation between them and the energy changes during the chemical process physical process. Hence it is called thermodynamics. Thermo means heat, dynamics means changes in the number of reactions, whether during the chemical reaction or physical process. So this is how the definition of thermodynamics. Okay, so what is next? What is first law of thermodynamics? The next part is first law of thermodynamics. So first law of thermodynamics statement is nothing but energy neither be created not to be destroyed. It convert only one form to other form. So this is statement given by the first law. Means energy neither be created not to be destroyed. It can convert into one form of energy to other form of energy. Means the energy of the total system is constant. So what is the equation for first law? So that is first law equation, that delta U is equal to Q plus W. So also write the Q is equal to Q plus P into delta V. So this is the first law statement. So what is meant by the delta U is nothing but the internal energy. Q means what? Heat. And P means what? Pressure. Delta V is volume of system or change in volume of system. So that is how the first law statement, the energy neither be created not to be destroyed, and the equation about this delta U is equal to Q plus W. So W means work. Okay, the work is two types. We will discuss in the later on. What is expansion, what is compression. Okay, so we will discuss in the later on. So first law statement and the equations. What about the second law? The second law of thermodynamics. Second law of thermodynamics. So three ways the second law defined. The first way, second way and third way. The first way, the energy convert into the another process. It is not the means what? Input is equal to output is not 100%. One more statement is given here. The efficiency of engine, the efficiency is not equal to 1. And the last one, the energy is transformation is unidirectional. means what? High temperature to low temperature. So this is the way the second law of thermodynamics defined in 3 ways. Input is not equal to output means 100% true nahi hai. It is some limitations of first law overcome in the second law of thermodynamics. Okay, so engine efficiency not equal to 1 means work and energy supply is not equal to 1. And the last, unidirectional flow of heat means high temperature to low temperature. So this is the second law given in the thermodynamics. What about the law number 3? The third law of thermodynamics. So what is the statement of third law? The statement is that the entropy of pure crystalline substance is equal to 0 at absolute 0 temperature. Third law of thermodynamics, entropy of pure crystalline substance is equal to 0 at absolute 0 temperature. This is the statement of third law of thermodynamics. What is the concept of entropy? We will discuss in the part of the 9th point. That is, what is entropy, how the relation between entropy and the Gibbs energy, how the process is spontaneous with the entropy of system, whether increases, decreases. That points we are discussing in the part of entropy. Okay, so what about next? The next part is the thermodynamic process. So what are the types of thermodynamic process and how the temperature, pressure constant in the respective process. So the first process, that is isothermal process. So first thermodynamic process is called isothermal process. So what is meant by the isothermal? So what indicate iso means same, thermal means temperature. If the system, the change in temperature is having 0, that process is called isothermal process. If the process having change in temperature is 0, that process is called isothermal process. What about number 2 process? Adiabatic process. So adiabatic process is an example of thermos flask. So in thermos flask, the Q is equal to 0. Keep in mind, the Q equal to 0. So heat of the system is remains constant in case of adiabatic process. Number 3, isochoric process. So if the system having the change in volume is equal to 0, that process is called isochoric process. And the number 4 process, that is isobaric process. So isobaric process means what? Delta P is equal to 0, means change in pressure of the system is 0. That process is called isobaric process. Okay. So this is first law of thermodynamics, having the different process with the statements. If the process is isothermal, so delta T is equal to 0 as well as delta U is equal to 0. See, in isothermal process, what is the statement of first law? In delta T equal to 0, delta U equal to 0. So this much is 0 in case of isothermal. So the equation becomes Q equal to minus W or W equal to minus Q. So this is statement of first law in case of isothermal process. What about adiabatic process? Adiabatic process, Q equal to 0. Okay, so in case of adiabatic process, the Q equal to 0. So what is the equation? So delta U is equal to W, that is also equal to P into delta V. So this is the second process, adiabatic, for first law. What about the isochoric process? delta V is equal to 0. Means what? Delta V 0 means work is 0. Means delta U is equal to only Q in case of the isochoric process. What about isobaric? So isobaric process is not related to this one, but one more statement is here, that is delta U is equal to Q plus P delta V. So isobaric process means pressure is constant. So the statement becomes delta U is equal to Q plus delta nRT. So this is the one more equation for isobaric process. So this is isothermal, this is adiabatic, this is isochoric, and this is called the what we call isobaric process. So that is how the relation between the first law of thermodynamics, the equation with the different process. So one question is asked, which constant is the with respect to process? One question on the basis of this, and what is the equation of first law? So this is asked in the GPAT examination. What is first law of equation? Delta U equal to Q plus W. Delta U equal to Q plus W. And what is the process with the different process with the first law equation? So likewise this isothermal, adiabatic, then isochoric, then isobaric. Okay. So what about the next? What is the types of work? There are two types of work. One is expansion work and there is a compression work. So in case of expansion, the work is negative. And in case of compression, the work is positive. How? And what is the sign convention for that? See, the very important point. So work is two types. One is expansion, second one is compression, and another one, the work also depends upon the equation, P delta V type and the W max is type. So there are four types of work. So first is sign convention, second is a process related. This is a process related. This is sign related. Okay. So expansion means what? The work is negative, compression work is positive. So in this expansion means what? The expansion means what? System work is done by the system on the surrounding. So this is the sign convention. If system do the work on the surrounding, the work is negative, that is called expansion. Opposite to this one, compression means what? Piston is downward. Work is done by the surrounding on the system. So this is the statement about the compression. So that work is called compression. Work is positive. See, expansion means what? System work on the surrounding, and in this case surrounding on the system. So that is how to remember the work is negative, work is positive. Okay. So what is another type? Work process related, PV type and WMAX. So this is work on the basis of process. That work is called isothermal irreversible process. Isothermal irreversible process. and this work is called isothermal reversible type. Keep in mind, is very important, reversible type. So if the process is isothermal, no doubt, the process is irreversible, the work is P delta V. If the process is reversible, the work is W max. So what is the work? In case of this one, W is equal to P delta V. So this is formula. But in case of W max, the formula is W max is equal to minus 2.303 nRT log to the base 10 of V2 upon V1. And in case of the pressure, that is Boyle's law, minus 2.303 nRT log to the base 10 of P1 upon P2. So these are the two equations for W max. Minus 2.303 nRT log to the base 10 of V2 upon V1. In case of pressure related, minus 2.303 nRT log to the base 10 of P1 upon P2. So this is the equations for W max. Okay. So what about expansion? What about compression? What is the PV type? What is the W max type? So this much is the expansion, compression. So what is enthalpy, entropy? So the next point is that enthalpy of reactions. So enthalpy is nothing but total heat content of the system. It's called enthalpy. So it is also called heat of reactions. So how it is determined? See, in this case, there are two types of process on the basis of enthalpy. Okay, enthalpy means two processes are there. One is a exothermic process, and another is endothermic process. Okay, so enthalpy means what? Delta H. Okay. So in this case, exothermic process means delta H is negative, endothermic delta H is positive. So what is delta H for the reaction? So summation of enthalpies of product minus enthalpies of reactants. So if delta H is negative, the process is called exothermic, and if delta H is positive, the process is called endothermic. Okay, so formula is that delta H is equal to, or heat of reaction is equal to, sum of enthalpies of product minus sum of enthalpies of reactant. Enthalpies of reactant. If the enthalpies of product is more than reactants, the delta H is positive. If the delta HR is more than delta HP, so delta H is negative, so that is the exothermic process. So how the exothermic and endothermic? By giving the value of delta H. Okay. So what is the formula for delta H? So delta H is nothing but the formula, that is delta U plus P delta V, or we can say delta U plus W. So that is the value, that is the equation of enthalpy. So this is equation of enthalpy. Okay, so what is entropy? So this is a very important point. See that entropy of system is what? Entropy is nothing but the randomness of molecules. So we consider example here. This is one beaker, this is another beaker, this is a third beaker. So this is A beaker, this is a B beaker, this is C beaker. In this case, the solids are present. Solids are present. So in this case, liquid molecules are present. In this case, the gas molecules are present. So how they randomize? In case of solid, they are very close to each other. The molecules which are present in the solids, they are very compact to each other. In case of liquid, they are apart from each other, and in case of gases, they are very apart from each other. Means randomness of molecules that define the entropy. So in case of entropy, it's very minimum. Very minimum means randomness is minimum. So this is moderate, and this is a maximum. Means the entropy of gas is greater than liquid is greater than solid. Okay, so in case of the third law of statement, the entropy of pure crystalline substance, solid is 0. That is, the randomness of this molecule is 0 at absolute 0 temperature. So this is how the entropy. One more example, if we have H2 plus O2, formation of sealed formation of 2HCl gas, 2HCl, Cl2 gas, H2 gas. So one question is asked on the basis of what is delta S. So entropy is denoted by the delta S, change in entropy, that is the symbol is S. Okay, so what is entropy of the system? Is whether 0 or 1 or 2, positive, negative. So entropy of system is nothing but the sum of entropies of product minus sum of entropies of reactants. So how many moles are formed? 2 moles are formed. So this is 2 moles. Only gaseous moles are to be considered in this case. So this is a 1, this is a 1. So 2 minus 2 is equal to 0. The entropy of system is 0. Entropy of system is 0. Otherwise, some case positive, some case negative. Let's consider another example. Cs plus O2, formation of CO2 gas. So what is the entropy of the system? So product is 1 mole, reactant is 2 mole. So this is a 1 mole carbon, 1 mole oxygen. So that is a 2 moles. This is 1 moles. So answer is delta S is negative. How it is negative? The number of moles of product is less as compared to reactant. Hence delta S is negative. Okay. So another point about the entropy with the Gibbs energy. So the question asked on the basis of Gibbs energy as well as entropy. About this, that the only 2 parameters are remaining. So question asked on the basis of spontaneous process and the Gibbs energy and the equilibrium process. See, keep in mind one more thing is that spontaneous process, equilibrium process, and non-spontaneous process. So sign convention is very important. If process is spontaneous, the delta S and the delta Z, Z stand for Gibbs energy, delta S stands for entropy of the system. They are opposite to each other. If process is spontaneous, delta S is positive, delta Z is negative. And if the process is equilibrium, delta S is equal to 0, delta Z equal to 0. If this process is non-spontaneous, delta S is equal to minus and delta Z is equal to positive. So this is the very important terms, and ask the questions on the basis of sign. If the process is spontaneous, delta S is positive, delta Z is negative. Keep in mind. Okay. What is the formula for delta S? Delta S from the Q upon temperature. So this is formula for delta S. And what is formula for delta G is equal to, that is delta H minus T into delta S. So this is Gibbs free energy change, and this is the entropy of system. So these are the two formulae. On the basis of this, we have derived the sign conventions. So this is how the important terms we are discussing about the thermodynamics. So on the basis of the randomness, entropy, that is spontaneous, equilibrium, non-spontaneous. On the basis of this, the questions can be asked. So this much part is sufficient for the GPAT examination. Thank you for watching the video.